this is my second talk. It's about writing a TCP analysis expert system, which is something which I've done over the last 1.5 years in secret. Nobody knows about it except 2 or 3 people from my team. So when the time came up to submit a talk, usually what happens is Janice tells me how many slots I need to do. And then I say, well, I have no idea what I'm going to do, but yeah, put me down for 2. And then at some point in time, I need to define what I'm going to do. So this time it was like, hey, why don't I talk about something that I've done for 1.5 years and which I've done so much that I can talk about it even without a slide deck if I needed to. So this is it. And what we're going to do is actually so that it's not totally boring for you, because showing you my code is probably going to be totally boring for you. We're working through trace files, of course, and checking them for interesting things. And what I want to do is to run them through my prototype and show you what the prototype says, and then verify what we think it is. And maybe the prototype is better than we are, or faster. I hope it's faster at least. Maybe not better. And so I will end the thing after a couple of slides with live stuff. So if you fall asleep in the first 25 slides, I will wake you up, okay? Good. So my name is, and this thing doesn't work, is Jasper Bongertz. I'm working still for Airbus Cybersecurity. I've done network analysis for quite some time. Started with networks by Sniffer Pro. Actually, the Sniffer Pro thing is interesting because in Sniffer Pro, if anybody worked with it, the time columns were on the right. Which means that my time columns in my Wireshark profile are on the right. And that's the right side, right? Because handshakes are on the left, and that's the wrong side. So, just kidding. Everybody does it as he wants to. So, I also done writing a program called Trace Wrangler. I have to admit that writing Trace Wrangler was important for this project because I'm reusing all the code base that I need to read a PCAP, dissect the stuff, and then put the analysis stuff on top of that. So without Trace Wrangler, this one wouldn't have been possible. And I also write a little blog, packetfoo.com. Gets about 800 to 1,200 visitors per day. So guess what which article is read the most? How to steal passwords with Wireshark. That's the #1. And it will always be, probably. And a little story to that one. I wrote it because I got pissed off by all the Twitter things telling you, this is how you steal passwords with Wireshark, and then you read the article and it's total bullshit. So I wrote an article that tells you, this is how you steal passwords with Wireshark, and then I debunk all the stuff that you think you could do. Like telling you, hey, you need a spam port. Oh, you don't have administrator right on a switch? Yeah, too bad for you, you can't capture them. So at the end, usually the readers are like, hey, this looks like I can steal passwords with Wireshark. I'm like, yeah, you can't. Because otherwise it would be stupid. Yeah, so read the article if you want to. If you know that I wrote it this way, it's more fun to read, because it's like, I'm totally telling you how to do this, and I'm like, no, you're not going to do this, 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 this. So, okay, anyway. TCP expert systems. Who has worked with a TCP expert system before? Who has seen one? Hansang has seen one, I know that for sure. Nobody else, you have? Really? Okay. So what they should do is analyze all the available TCP packets, diagnose various relevant, and there's a reason why there's like a underline there. It should be relevant, because I don't need symptoms that aren't relevant. And it should help the analyst find the problem. Okay? So I don't know if you've seen this one. This is Sniffer Pro. And when I started with Sniffer Pro, somebody told me, like, there's an expert system in there that can tell you what is bad in your network. Look at that column. And I was like, act too long. Oh my God, that sounds really bad. What am I going to do? And me, being now not in 2003 anymore, but in 2018, is like, this is total bullshit. Nobody needs that symptom. It's completely, forget it. Yeah, same with window frozen. Sounds like a packet coming from the ice cream truck, but what's a frozen window? Yeah, it means that the window size stays very constant over some time, And I'm like, yeah, so my window is completely empty all of the time, so it's frozen. Is that a bad thing? This is more like a symptom that tells you, hey, something is working good. Yeah. So this kind of thing was annoying me quite a lot, and I think these are symptoms that nobody needs because they're good for nothing, in my point of view. So fast forward, and we're having this. That's the expert system in Wireshark, and it's better because it gets you a little more interesting stuff, but still there's, from my point of view, I never open that window. I never do, because I don't know, yeah, there's stuff in there, but I don't care. So that's, again, is a expert system that I don't use. Who uses that expert window? Okay, a couple of you do. Well, keep going, keep doing it. If it's helping you, it's fine. For me, it's like, oh, I prefer to scroll. Mainly because Laura doesn't allow me to, so. Okay, so something I stole from Gerald, again, is Pola, which is the principle of least astonishment. That means something should behave as expected and not surprise you with something that you get that you don't expect. So the first sniffer expert thingy is like something you don't expect. You get a lot of stuff and it's not useful. So what we want is useful symptoms. We want not to getting swamped, because if somebody tells me, hey, you got 1 million problems, I'm like, yeah, but triage is, I only have 24 hours a day, so Rated by criticality would be nice too. That is sometimes quite hard, because you don't always know what's critical and what it's not, but there's where I'm going into some years of experience as a network analyst and saying, this is not good and this is, we can ignore this. So I'm trying to apply a rating, like a point system, to symptoms and saying this is more bad than this. And then, if possible, provide a recommended fix, because what good is an analysis report if you tell the customer, like, hey, to fix this one, you should do this. Because that happens a lot. They tell you, oh my God, your network is totally broken. By the way, good luck. What you need is somebody telling you, okay, you have this symptom, and I would recommend you do this to fix it, because then it's useful. Okay, so I have a little thing to keep you awake. It's only a handshake, and it doesn't work. And maybe you can find out why. Louder? Sync, no egg, right? Instead we get what? Reset. So this is like a conversation like this. Hi. Hi. Shut up. Yeah, so why would something like this happen?
Server's down.
Huh? Server's down? Yeah, it's a possibility, but it does react on the next SYN coming in, so it's not really gone. Yeah, but the conversation is not even started yet, so doing a keep alive without having the handshake is not going to happen. Yeah, so you need to handshake first, and then you can do the keep alive stuff. So right now this looks like, hello, hello, I don't want to talk to you. Yeah? Sake? TCP, okay, I'm too far away somewhere. Okay, a health check. No, in this case it wasn't. I have to admit I know exactly what's happening here. What's happening here is I was being a stupid guy writing code, because I'm not a programmer, I'm just writing code. What I did is I wrote a program that sends messages, and I misread, or to put it this way, I didn't read the documentation, because who does read documentation? Not me. So I put a timeout on the socket of 10 seconds, and no, I didn't, because it was milliseconds. So I said 10, and this is just a little bit too slow. So the SYN goes out, the SYN egg comes back, but in the meantime, my socket's like, I'm shut down, thank you, reset. Yeah, so this was, well, if all programmers would find problems like this as quick as I did, because if it didn't work, I fired up Wireshark, I found the packet and was, I'm an idiot. That was like a fix in 5 minutes. But this is what happens. Easy, right, if you know what's happening. So there's a couple of symptoms you could do here, looking at stuff and saying what could be the problem. If you know enough about TCP, there's only a few things that could have happened here, and that is one of them. Well, I got another one of those. And maybe Sake recognizes this right away because I stole it from ask.wireshark.org. Still, the conversation doesn't work, and it's not a timeout thing. And it still says synac reset. I don't talk to you. Why? And you can see it's repeated all over. So what do we see here? What is like a little bit checksum error? So what's with the checksum error? Is it a real checksum error? I would say it isn't. Why? Because if a packet with a checksum error travels all the way to the other guy and he sees, oh, a checksum error, he's like, bling, discards the packet. There won't be a synac, because if the checksum is real, this checksum is really broken, it is discarded on the receiver side, but the receiver says, hey, yeah, I want to talk to you. So it can't be a true checksum error, and in fact, it's only because I captured locally on a system, which you should never do unless you know what you're doing, which I think I can say for myself. I know what I'm doing. Okay, so it's not the checksum error. What else? If you compare the two, what is in there on the lower one that is not up there in the upper one? The timestamp. Who knows how timestamps work? Nobody, right? Nobody? Really? Hansang, you don't know how timestamps work? Sometimes. Okay, so in this case, it's the timestamp, because this guy is sending a TS val of this number, and if you read the RFC, which few people do, I do, this one here should be this one as a copy. So it needs to reply with the exact same number, but it doesn't, and that makes it an invalid synac packet because the timestamp value that is sent back is not the original, and that means that the client in this case says, okay, this doesn't seem to work, reset. So we have the same, if you're only looking at the flags, it's synac reset, but total different reasons why. And we need an expert system that is capable of telling you, yeah, I've seen the timestamp, then don't match, so I think this is the problem. Or I don't have timestamps, so that couldn't be the problem, but the timing is maybe, in this case, I would say for the upper one, it could be that the socket is already closed again. Yeah, or that you have some other kind of mechanism that does something like this. So we need an expert system that will tell you, if you see this, okay, is it a timestamp thing? No. If it is, yeah. Okay, so that's what we need. All right, so a little sneak peek of what I've done is this. That thing I wrote is a command line tool. The reason for this is quite simple. I want it to be an engine, not like a full-blown thing like Trace Wrangler already is. And I'm hoping that I'm capable of porting it to other systems than Windows in the future much more easily than the GUI stuff. It's written in Delphi, of course, because I'm using the sources from Trace Wrangler. And I'm doing that on purpose to annoy you, Sake. Okay? No, basically, this is a prototype. So right now I'm testing stuff out, and it's not even nice code. It's nested case statements a lot. So that is not a good thing. And when I'm done with this, I will maybe transport it to a whole different thing using a state machine, which I think is much more useful. But I need to find my bearings first. So this is a prototype, and the first thing you write should never see the light of day. So this is why this is a sneak peek. What I'm doing is I'm reading the whole PCAP file, and then I'm doing an analysis of each TCP flow that I find and give you one comma-separated line per conversation. It's a bit hard to read, but you can tell it with a command line switch to write it to a CSV file right away and then open it in Excel, and then it's easier to read. And I have a friend who's already using this for a web service, and well, for him it's easy to parse that stuff out of the lines. I colored the interesting things here. That is, if you look up there somewhere, it says symptoms. Up here, whoop, there it says symptoms. And that is what we have down here. Routing duplicates, SYNAC retry, packets after reset, and multi-server TTL. Yes?
When you're writing this, are you using something like T-Shark to break out the TCP flows, or are you doing the TCP?
It's all my code, completely. I took not a single line from everything else. Everything in here is written by me. Reading the PCAP, dissecting the packets, everything. So, and I mean, this one is not open source yet, but TraceWrangler is, and most of this is in TraceWrangler. So if you want to look at it, get the source code and look at it. But it's Delphi, so nobody knows what it is, except me and the Russians. OK, so this is how it looks like. And now we need to go into a little more detail. The challenge with TCP analysis is it is easy to learn and hard to master. Because it requires, you need experience. And then you need experience, and then you need experience. And it's a little hard to get. So I'm happy that you're here, because SharkFest is about to give you hints and pointers to build experience more quickly. So showing you things that you may have not seen before, and so that you can remember them. Yeah, an example is, hey, a reset packet, is that bad? Is a reset packet bad? Well, let me click on that button, because it depends, okay? It could be a reset that tells you, oh, this connection is totally broken, we have a critical error in here, so yeah, that is a bad one, but a lot of times it's just an Internet Explorer telling you, yeah, I'm done, and tearing down the connection faster than FINAC. So it depends. Then there's a challenge that if you're a programmer, you may not be a TCP expert or analysis expert, so writing an expert system as a programmer and not being a TCP experienced guy could end up in the stuff that we had before. So I guess act too long is a useful symptom, right? And the answer is nope. And window frozen is just as useful. So there are three truths in TCP, and that is important if you're writing an analysis system, or even if you're your own analysis expert system. So if you're not writing code, but analyzing packets. First of all, there's the truth that the client knows. And client meaning the TCP client, the guy sending the SYN. It doesn't have to be the physical client or the physical server or whatever, but the one sending the SYN for me is the TCP client. He knows something. He knows I've sent this SYN. He knows I don't have an ACK back yet or a SYN ACK back yet. He knows his state, for sure, 100%. Then we have the thing that the server on the other side knows. He knows, oh, I got a SYN and I answer with a SYN ACK, but I haven't gotten the ACK yet, so we'll see. So that's another truth. And both of them are 100%. And then guess what? Then there's what the trace contains. And it is important to notice that there's no no's here, because we get packets that were captured, and there may be packet loss, but packet loss may be because we didn't capture it right. So what we see in a trace is like something we need to work on, but it's not a truth. It's something we get and need to work with. So that is the biggest problem we have in writing any kind of code that tries to analyze TCP packets, because you never know what you're getting. Most people think, hey, a TCP analyzer is really easy. You do the thin SYN-ACK ACK, and then something comes by, and then you do an analysis. And I'm like, okay, what happens if you don't have the SYN-ACK, only the SYN and the ACK? What are you going to do? It's like, yeah, assuming it was there, maybe because there was the ACK, yeah, you could do that. But that is something that you need to be prepared for. Or you don't have the handshake at all. Or you don't see the tear down, or tons of other things. So you never know what is going to happen. So the key factor is, where are you capturing? And you can have problems with timings. You can have packet out of order situations. There could be packet loss, which is something that could happen because the capture device isn't fast enough, or it was real packet loss. And then you could have duplicate frames. one of my favorite, because that happens quite a lot. I had a very, very seasoned engineer at my company once who told me, oh my God, this trace looks so bad, I got 30% of retransmissions. And I was like, wait a second. Nobody has 30% retransmissions. Nobody. Except there's exception from the rules, of course, but in a general setup, you don't have that many retransmissions. Can I please have the trace file? Okay, thank you. Edit cap -d, deduplicate the packets, write it to a new file, zero retransmission. I think there was 2 maybe, of thousands of packets. So duplicates are a big problem, because if you want to see the TCP expert of Wireshark go completely crazy, feed it with a PCAP file that has duplicates. Because then it will say, oh, retransmission. No, it's just a duplicate, but the expert doesn't know that. So my expert does, which may not be a smart thing, because I honestly think you should deduplicate your packets on read before feeding it into an expert. But I wanted to do it in a way that you can feed it anything and it will still detect that it's the duplicate. So it will do that. Also, that is like a symptom, right? If you get a packet capture and there's duplicates in there, I want a symptom that says, you idiot, you've got duplicates. Or without the idiot, maybe. Okay, so everybody's still awake because I put some time into this. Animating slides is work. So please watch my animations. So we have 3 truth examples: the client, the server, and the laptop. And what can happen is this. There's a packet, and the client knows it has sent it. The capture laptop has seen it, and the server has received it. Wonderful, we all are on the same page. Everything is perfect. Now the trouble will start. We're sending a packet, and it gets lost. So we think it's perfect, maybe, but this guy didn't get it. So what we know is not the full truth, at least in the capture. And then, of course, there's the other example, that is this. Sending a packet, it gets lost on the first part of the journey, and both are, we don't know anything. Okay? And then there's the fourth. And the fourth is this one. So the capture system was too slow to pick up all the packets, so it got through perfectly fine, but we think it's lost. So in that situation, it gets a little complicated sometimes if you're talking to people who don't believe you that the packet was there and not a problem. You can work around that if you know how, because usually for that packet that went all the way over, you will get an acknowledge back. And most of the time, because an acknowledgement is like this big, you will get it in your packet capture. So you see an acknowledgement for a frame that you don't have. And Wireshark, for example, will tell you that I have an ACK for an unseen packet. And that means, congratulations, your capture setup was too slow. The packet capture machine was not good enough. You're seeing acknowledgements for packets that you don't have, which means, one of a couple of things. It could also be asymmetric routing, so packets are taken this way, and you're here on that way where the acknowledgements are coming back. So there's a couple of reasons why that could happen, but all of them are basically bad for analysis. So that would be a symptom again. And then there's something new I invented. Maybe you've heard of it, maybe not, because if I pretend to have invented it, you haven't heard of it. It's a 6-tuple. You know what the 6-tuple is? Who knows what the 5-tuple is? Okay, who doesn't know what the 5-tuple is? And the rest just doesn't care, okay. Good, 6-tuple, or 6-tuple, or however I should pronounce it. Tuple, 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 potatoes, potatoes. TCP analysis usually requires the 5-tuple, so you have UDP or TCP, which is one of the values, then you have source IP, destination IP, source port, destination port, and done, you have the conversation. The problem is if you have port reuse, and that happens a lot, at least in the captures I do, because sometimes I capture for days, weeks, whatever, you will get port reuse. And if you're using the 5-tuple, you end up with tons of conversation, not just one. So I introduced a new thing, and that is the initial sequence number, because the new conversation will have a new sequence number in the SYN packet, and if I see that one, I'm like, okay, cut, this is a new one. The interesting thing is it's not that simple, of course, because sometimes if a connection setup doesn't work, the client will at some point retry with a new sequence number when all the mayhem before that was declared as dead and finished. And then you didn't have a conversation really, but a new one is starting with a new sequence number, but we can still maybe call it another conversation, right? So I have a couple of situations where there's a port we use and it's not really that easy. And I will show you one if we have the time for it. And that is a really interesting one because it made me program something into my analysis expert that is like a very special case. Because one side thinks the old connection is still alive and the other doesn't, and then they get like, this is my sequence number, this is my acknowledge number, and it's like, oh, this is for the old one, it's a new one. If you're writing a system that is looking at the sequence and ACK numbers, it gets totally confused sometimes. Okay, so TCP handshake. I hope everybody knows what the TCP handshake is. If not, you should go to one Fin SharkFest class maybe first. Okay, so very important. Why? Because it has TCP options. Very, very important. I think Betty once did a talk at SharkFest, 1 hour, 15 minutes, just over the first 3 packets. And I think I could beat that, and probably most of us presenters could beat that, like, oh, I can talk a day about the handshake if you want to, because there's so much stuff going on. Who's who? Who's the client? Who's the server? Very important. Sometimes you don't know. If you don't have the handshake, it's like, who is the one, what? Oh, initial route trip time. I'm buying an N if somebody has one. It's the initial round trip time. Very important too, especially in the later game when you're having retransmissions out of order, stuff like that. The round trip time, as Hansang in his talk said, is very important to know. Was it possible for the guy on the other side to know that something is lost, or is it so fast that it needs, or that it should have been, or must have been an out of order arrival? So the round trip time is very important.
Do you take into account that sometimes your through handshake is with an intermediate device, so you have a fast round trip time for your CNC and afterwards the full system to the back end to the larger round trip time?
So the question is, do I take into account that there are handshakes that are not relevant for the rest of the conversation? Not yet, no. But if you have traces like this, get them to me and I will put it in. A lot of what I've done here is basically scraping crazy PCAP files from all over the place and trying to diagnose the symptoms exactly and correctly. And if you ever write an expert system, it's the one thing that I recommend. Get as many samples as you can, and then, before writing anything else, start unit testing. I don't know if you heard about the concept of unit testing, but that means that I have like 24 PCAP files where I know what the symptoms are. So every time I change my code, I run all the tests against all my PCAP files and compare if the symptoms are still the one that I expect, because very often they change. You do a minor tweak on this side, and suddenly another case completely looks different because I made a mistake, or that symptom was in fact in that trace, but I didn't see it yet. So whenever I do that, I always run my tests and I can tell, okay, it still works or it doesn't, and if it doesn't, I know why, or I find out why. Okay, challenge is here determining the handshake packets. If you ever tried that in Wireshark, okay, then you know what I'm talking about. If you haven't, that's a really interesting challenge if you want to challenge yourself. Try to write a display filter that will isolate the first 3 packets of a TCP conversation. Huh? You can do it. I can do it too, but many other people maybe haven't tried yet. Because the problem is not the SYN and the SYN ACK, because why? Because we have the SYN flag. So we just say, hey, if there's a SYN flag, it must be handshake, right? The third ACK is the problem, because very often you're saying, hey, give me the ACK. But the TCP display filter system is not capable of making you build a filter that says, give me the ACK if it's the sequence number 1 higher or that you expect after the SYN ACK. So you cannot dependent filter on packets, not in an easy way. There's some tricks that you can use to do that. And I wrote a blog post about it. It's from, I don't know, last year or something. You can filter on it, but it's complicated. And it gets a lot more complicated if you're writing an analysis system, because then you need to expect that packets are missing. You will only have the SYN-ACK and the ACK, but not the SYN. Or you have the SYN and the SYN-ACK, but not the ACK. And then you need to code around it and say, okay, but I've seen the conversation continues after the SYN-ACK, and I don't have the ACK, but there's more, and it's not the ACK that I need, but I need to assume that it must have been there, I just don't have it. And I have traces. Well, that is the case. It's really rare, but it happens. And I still want to be able to diagnose systems or flows that way, so I'm having a lot of assumption code in my code base already. So the problem here is, what if I don't have any, or just some, or if they arrive out of order? Which is also a funny problem. If you have a handshake where the packets are out of order. I have one example in my traces that I'm going to show you where that is the case, and it looks really strange. Okay, so TCP Investigator, that's the name of my prototype. That's mostly because I think I have the URL domain registered for a couple of years now. So it's mostly focused on handshake and teardown, because you need to get that down before you do anything else. And to investigate the full conversation, that is something that I still need to add. What I'm doing already is things like, if I see a packet, is that the sequence number that I need to see next? Because I know the previous one, I know the length of the previous packet, so I know which one should come next. If I don't see it, I will count that as a gap, but I have no idea right now how big the gap is, how many packets are missing. So it's a very crude diagnosis right now that there's something missing. But still, you get a percentage in the end telling you how many gaps there were. So if you have a file that tells you, I got 100%, then it means there are no gaps. Right now I have 102 different data points. So for each TCP flow, I'm keeping 102 data points. And that, I mean, if you would have told me, like, if you're writing a thing like this, you will end up with 102 data points. I'm like, seriously? I'd expect something like 30 maybe? And this is for handshake and teardown only yet, so it will get worse. I think I have a debug routine somewhere that prints me the size of that thing, and I think one record right now is about 1 kilobyte for one flow. If you have 1 million flows, 1 million times 1 kilobyte of data just for this kind of thing. So I don't know if yeah. So full rewrite may be necessary at a later stage, I already said that. And that's also because nested case statements are not very elegant. That's what I'm doing right now. So let me just show you the data points. It looks like this. And the amazing thing is that I documented the stuff for myself, because otherwise you get lost completely sometimes in your own code. So I also built new data types. One of the new data types I built is, let's see. Where's my mouse pointer? There it is. The TCP sequence data type, which may be a little bit surprising because a TCP sequence is a 32-bit value, right? So I could just use a 32-bit value. But sometimes you have TCP conversations that wrap the sequence number. So I built a new data type that tells me how many wraps did I have. So I have the sequence number that is current right now, and I know how often it wrapped, which is sometimes important if you're comparing if a sequence number is higher or lower than the other one. You need to know if it wrapped or not, because otherwise you will see a later sequence number that is smaller than the previous one, but it's a later one. So I built this kind of thing. And there's other things in there, like IP ID increments, for example, here. Yeah, that will tell you in what jumps the IP ID is incremented, which may be surprising again, because this has nothing to do with TCP. But maybe you know that if you're looking at retransmissions, sometimes you need to know if the IP ID is a newer IP ID than the original packet, because sometimes you can diagnose out of order by looking at the IP ID. If they are swapped, then the IP ID is lower than the previous packet. So to be able to do that kind of thing, I first need to find out if the IP ID increases, because if it doesn't, I cannot use that kind of trick. So that's why there's things in there like that. And I'm doing stuff like server push counts. How many push flags did you have? And all that kind of stuff. So you could count that as stuff that is happening in the conversation already. But right now, there's no diagnosis for this kind of thing. I'm just doing that because it's easy. All right, So, and I already said, maybe I'm going for a state machine because this, while I was writing this one, it screams like, hey, do a state machine. Because what you're basically doing is you're having a state of the TCP conversation that you see from the packets that you have, and whatever next packet comes in will change the state. So it should be easy to, no, it's not easy. It should be possible to write a state machine. Yeah, but I'm not sure yet. So here's a code example. I'm sorry, this is Delphi code. It looks very much like the code that you probably have seen in the university if you ever did computer studies, because that is like the pseudo language that they use. So this is one of the things where you can see, okay, I'm checking for, did the sequence number wrap? Okay, so if yes, I will add a symptom to the analysis saying, hey, this is a conversation where the sequence number wrapped, because I want to know that. And then I say, hey, is there a TCP SYN flag in the parser flags? So is this a packet that is either a SYN or a SYN-ACK? And if yes, take a look at the handshake state. Where are we right now? Do we have anything yet? And what you need to know for this part of code is that there's an initialization code that if the SYN arrives for the first time, it will create the new conversation and everything, and this is when you add packets to an existing one. So you should never be in a handshake state where there's a SYN packet again that is not a SYN-ACK. And so I'm adding stuff like handshake out of order messages and all those things. And Sak is already debugging my code, I can tell. Okay, so the other thing is that I think probably that a good analysis system for TCP needs to be multi-pass, meaning you need to run over the packets a couple of times. I'm not 100% sure yet how many passes I will need. Maybe it's 2, maybe it's 3. I'm pretty sure it's not going to be 1. For example, if you have SEC edges, like selective acknowledgements, there's a problem with you want to track when the blocks that are missing are coming in, and you only have so much time to do that, and you're moving over the packets forward, not backwards. So you need to find the interesting stuff and then do a second run to fill in the gaps, so to speak. Or you could code it in a way that you go backwards to fetch the stuff, but that is highly unpredictable because you never know how far you need to go back. Or you need to add more data points, which makes it completely crazy. So I think I'm going to do a two-pass thing, and maybe I will stumble across some things that I find out in the second pass that require a third pass. So it will be maybe 2 or 3. I think it's going to be 3, actually. Is it possible to? I think I need to come closer because I'm hearing so bad.
Is it possible to multi-thread your application, like have a thread that
okay.
is calculating your TCP packets as it is moving forward, and then one thread which once it detects a packet drop and is waiting for a selective acknowledgement, just waits until it comes
okay,
back,
yeah, I understand. I'm not that good of a programmer, but yes, probably. So the question was, can you multi-thread that thing so that you have your first thread going through all the packets, and if something happens, you have a second thread investigating for you? Probably yes, but I'm too bad for programming this kind of thing. And also, I'm shying away from multi-threading right now because debugging a multi-threading application when you're still in the fog and don't know where you are right now is adding complexity that you don't want to have, because you never know, is it because I'm multi-threading, or is it a real bug that would happen even if it's single-threaded? That's actually the same reason why Thrace Wrangler is single-threaded. I run into enough trouble already without multi-threading it, but as soon as I get there, I can rewrite or add more functionality to it to make it multi-threaded, maybe, yes. Good question, thank you. So, yeah, the SAC edge box I already said. Symptom detection, there's a couple of different symptom detection classes that you can have. One is single packet is enough to detect a symptom. For example, you have no MSS option in the handshake. It still happens, but it shouldn't. Yeah, every handshake today of a modern TCP stack should have the MSS stated in as an option in the handshake. And what I found in my years of doing network analysis, that if you're looking at a huge amount of packets, you don't have the time to check each handshake for, hey, do you have a MSS option? Do you have a window scale option? Is there something else strange? So the sheer amount of packets makes it quite hard to find symptoms like this, because you're not looking into that, because it takes so much time. But an expert system, that's easy. Yeah, it can just look at this thing and say, hey, you've got no maximum segment size. Then there's conversations, where you need to correlate packets of the conversation, like packet loss and stuff like this. And the third one is global, meaning it goes over more than just one conversation. For example, if you don't have a handshake in a conversation, you're missing one very important thing, and that is the initial round-trip time. So you don't know what the round-trip time is. But maybe you got another conversation between the exact same IPs in your trace file, and there is a handshake, and then you can say, hey, if those two IPs are talking within a round-trip time of 20 milliseconds, I can assume that the other connection was quite similar. Of course, it's an assumption. It could be wrong, but if you have enough of them, you could say, hey, let's get an average IRTT and assume that all connections that don't have a handshake, because I started the capture too late, have the same thing. Okay, so that is some stuff that you can also do just to get there. And we're done with the slides. Hooray. Okay, so now we're going to look at actual trace files and check out what happens. And then we do maybe a Q&A. All right, so. I have traces somewhere. So first things first, if you're doing scientific stuff, one of the rules is go with an example that has no problems first, right? Like get a baseline of simple stuff. And this is one of the samples that I use a lot because it's perfect. There's no problem at all. It got a SYN, SYNAC, ACK, FIN, ACK, FIN, ACK. No out of orders, no retransmissions, no packets lost, no nothing. This is just like the dream trace of every network, no, not every network analyst, because then we would out of a job, but it's like the dream conversation of. So let's try something and say, well, I got the same traces here. TCP Investigator. If you run it, it will tell you it has some options. But the main thing is you just tell it, this is the capture file. Run on this capture file. And the options are write the results to a CSV file instead to the screen, because sometimes writing it to the screen doesn't make any sense for you. But if my colleague is running that as a external program that he calls, he needs standard out to get the values back. This is why. Force override just overrides the CSV file. Quiet mode will not put out debug messages. You can tell it to omit the header line, where it tells you what the values are in verbose mode is also there. We don't need that, so let's just do HTTP, this one. So it's quick, but of course it was only 18 packets or something. So what we need to look at here is, it's hard to read on this, so what I'm going to do is I'm going to write it to a CSV file. So it creates a HTTP sample.csv. It puts it into the same directory with just the same stuff. And since I'm there here, I can just open it in Excel or Excel if you want to. And maybe you can make this bigger. Bless you. Handshake state is complete. We believe that because we have seen it. The teardown client is FIN ACT. So the client sent a FIN and it was ACT from the server. The teardown of the server was also FIN-ACT, so I know I got a full handshake and I got a good teardown. I have no resets, which is not surprising, because if you're doing a FIN-ACT, it's like thank you, goodbye, gentleman-like, and not like a slamming the door, go away. So no reset state. I have no symptoms. What a surprise. So that's good, right? Because we had no symptoms either, and we have some of the best network analysts in the world here. So what else do we have? We have the client IP. That may seem a little bit funny because we also had it in the front, but this column is just telling you this IP was the one sending the initial SYN. Because sometimes you're confused, who is the client, who's the server, and I can need that. I need to know who's the client. And there's an interesting case that when you don't have the handshake at all, you don't know who the server and who the client is. And I have a few lines of code in my code base that is looking at things that only the server would do. And if it sees something that only the server would do, which right now I can't remember what they are, it will swap all the values in my data record and swap client and server, because then it knows, oh, this is the client. And then it will swap them. So first IP seen is the client IP, which is not surprising because the SYN is coming from the client, but sometimes if you have out of orders, it may be different. Client detected is true. Common MSS 1460. Gap ratio 100%. We got all the packets, no gaps, no packet loss, basically this means that all the sequences that we saw matched the next expected sequence number. So if this number goes down, you have packet loss somewhere, or out of orders, or whatever it is, but the sequence was not perfect. This is a perfect sequence. Total symptoms score is 0. Very surprising because we got no symptoms, so that's good. Initial round trip time, yeah, well, this is a representation thing. I count this in nanoseconds. That may be a little bit surprising, but I'm a little bit, how can I say this? I'm too lazy to do something else. And nanoseconds is perfectly fine because you will not get any delta timings or whatever that is more than nanoseconds. So I went for the smallest denomination to show the time. And if you need to know how much that is, there's a calculator that you have, or you put the formula into Excel or whatever. So how many SYN packets do we have? 1. Because sometimes there's SYN retries, right? So somebody tries to SYN, then the counter goes up. How many SYN resets do you have? So how many of these SYN, I don't want to talk to you, comes back from the server when the port is closed? 0. Client fins 1, server fins 1. So as you can tell, this export is made for machine parsing in the end, so that you can know what the state of the conversation was. And that was a basic goal here. So what else do we have? How many packets were discarded by the server? How many for the client? Discards in this case means if I find duplicates, I discard them because they mess up my analysis, and the counter will go up. So if there's duplicates in there, you will have a higher number. And then stuff like client TTL, server TTL, client MSS, server MSS. And what I've done here is giving you a display filter so that if you load the PCAP into your Wireshark, you can just copy-paste the display filter into your Wireshark and get that conversation right away. Because sometimes you get a CSV file that hundreds and millions of lines, and you find one that is interesting and you want to carve it in Wireshark. So I give you the display filter line to find it. And I also, because it's much faster, give you a BPF, because then you can run it with a TCP dump carve instead of T-Shark or whatever. So that's the data points that you get. Yes?
About the gap ratio,
yeah.
Do you have something similar to take into account of artifacts of capture drops, not new drops?
No, not yet. So I don't have a drop counter or something like this, because that's in the future. So it's a good idea, but not yet, no. All right, so that was a simple one because there's no symptoms. I used that one to explain to you how my CSV file looks like. So now let's try another one. Let's go for TCP Investigator number 2. Yeah.
Trying to determine where the traces from client side and server side. So you identify the role of the state of the client and server in TCP, but what about trying to say there's traces from this side? Because you're going to get different messages.
If I know who the client and the server is, the question is why do I define who? Yeah, that's something that I also do, and that is a funny thing that you will see probably in this. I'm going to the extreme of saying, am I at a span port? Am I in a tap situation? I'm doing that kind of thing. And the funny thing is, if I put in a trace file with like hundreds of TCP conversations, you will give different results. It will tell you this conversation was captured on a span port, this conversation was captured on a tap, which is not possible. But I need to fine-tune it because it's not really working right now. So I'm doing this client and server detection thing so that I can assign the symptoms to the client or the server. Because as an analyst, it's important who you're going to blame. If I only tell you there's like a symptom XYZ and you don't know which side it was from, that's not helping. Yeah, is that what you, okay. Yeah. All right, so I have a number 2, which is synac reset. Let's look at the trace file. It looks like this. And I think that is the timestamp one that I showed you before. You can see the TS val is 1474 something, and should be the TS rec should be the same, but it isn't. So this is the one where the conversation is torn down with the reset because of the timestamp mismatch. So let's see what our CSV has to tell us about this one. So the CSV that we have looks like this. And the only thing we care about right now is the symptoms. No, it doesn't. Why doesn't it? Okay, interesting. Yeah, so this looks like a typical demo situation where it doesn't work. Or maybe I got the wrong trace file, that's possible too. So let's try the next one and not waste any time. It's a prototype anyway, so I can make mistakes as much as I want to. Next one is this one. Okay, yeah, that's a funny one. I like this one. Let's make it bigger. You want it bigger? Smaller? Yeah, you're sitting in the first row. Who wants it smaller too? Nobody? Okay. Just a little, okay. I think this trace is something I've shown Lundy already, so he knows what it is. Basically, he was the one who knew exactly right away what the problem is, and everybody else was like, oh, what is happening here? Since when do we have synac fin as a sequence? So let's see what the expert says, right? I mean, does anybody know what this problem is? Do you have any idea what happened here? Yeah, I think it's too loud up here. I need to come down again.
So the client is sending a SYN,
yeah.
And the server sends a SYNAC, but before it could get, like, the client knows that it has got an acknowledgement, the server again sends a disconnect message.
Okay, so you say the server is sending a disconnect message before the handshake is complete.
Even before the initial connection has already
Yeah,
sent.
no, unfortunately not. It's a capture issue. Why? Who said that? You. What's the capture issue?
Box can process the traffic fine, but it just saves it. I've just seen it before where it's...
Okay, you think it's an out of order thing. Okay. Let's see. Let's hope that my expert this time does what I wanted to. Stupid software. Okay, so did I run it already? No. Number 3, please. Give me the CSV. There it is. Zup. So what do we have here? It says handshake is out of order. So yes, you were right, John. Yeah, it's a capture issue. If you look at the trace, and that is something that Christian Lundy, he saw right away, is that the SYN and the SYNAC are in perfect order, but the FINAC is coming into the capture too soon, and the keep alive that you're seeing is not a keep alive. It's the handshake ACK, but it's just one packet too late. So this is kind of the symptom that I'm diagnosing by looking at the sequence numbers and seeing, yeah, there's the sequence number, that's next sequence number. The FIN packet coming in between has a sequence number that doesn't match anything that I need at that point, so it's an out of order or whatever it is. But then I see the ACK and it's like, oh, now my handshake is complete. But I had some clutter before it was complete, so I'm doing a diagnosis saying my handshake is out of order. Okay, so this is the kind of idea that I have. I want an analysis system that will tell you, hey, don't waste time on this because it's just the packets were out of order, saving you time. Because if you're looking at this, and I used that trace, I think last year at SharkFest Pittsburgh, I used that to basically have like 10 minutes of, I don't need to do anything while you wonder what this is. Yeah, it's quite a great trace because you can taunt the audience and say, hey, it's only 3 packets, how hard can it be? Yeah, so with an expert system, it should be like, hey, ignore this one, we don't care. Okay, good. Next one, what's the next one? It's a port reuse thing. Oh, that is the one that I was talking about earlier. I still have a little time, I think. So, let me rearrange the columns a little because it looks too crowded here. You should at least be able to tell the IPs from each other. So at the beginning, we don't care. There's something red in there. Why is there something red in there? I don't know. Oh, it's because there's a 0 window size in there? Yeah, okay. SYNAC with window size 0. Maybe there will be a symptom in my diagnosis later. We will see if the expert catches that already. That's a quick win. I mean, that is when I was talking about things you can diagnose with looking at one single packet, like having a SYNAC where the window size is 0 is like, that's not right. Or at least that shouldn't happen. There's no easy fix for that kind of thing, but yeah. So let's go down, down, down. No scrolling, please. Yeah, scroll faster. So this is an interesting one because there's port reused, right? So there's another conversation starting that is using the same IP port, but it got a different sequence number. We have a sequence number here that is 22721743. Let's see what the original was. So let's mark this one. Go up to the first one. This is different, right? I've forgotten the number already, but I know it's different than this one. And an expert system is capable of comparing that very easily. So let's go back to where we were by going to next mark packet. How was that? I can never remember where the option is. Mark, next mark. I marked one packet, why doesn't it work? Okay, bug report. There it is. So port number used is something that the Wireshark expert will tell you too. That's a symptom that is correct. Now the funny thing here is that you have an ACK for an unseen segment. You have a reset, and you have another port number reused here. So I think I used that trace before in SharkFest, and the question was, why does the port reuse work, and why doesn't it work? Yeah, it works once. It doesn't work once, but it works the second time. Yeah. The simple answer for this kind of thing is that it is a timing thing. You can see that the second time it tries to use the same port numbers, it is so much later that the TCP socket state is completely cleared on the other side, so it's possible to reuse it. The first time he tried, or the system tried, it was too fast, right? So if you're a TCP expert who has read all the RFCs, you know that the normal wait time that you have until a state is cleared when it was torn down is what time? How long? What? Louder?
Twice
Well, in the end, it ends up like being 2 minutes or something. Yeah. So there's a formula in there with round trip time and whatnot, but 2 minutes is the normal one that you get. The funny thing is that you can see here that the second one works even though it's faster than within 2 minutes, but there's a reason for this, and that is, why does it work the second time even though it's still too fast? Because of the reset. The reset clears the state completely right away. So this time it works, right? So from an expert system point of view, that is something where you need to look at timing and say, well, this worked because, and this one worked because, and then I have to reset and stuff. I'm not even sure if I put that in yet, but the problem for me in this trace file was that there is a acknowledgement coming from the one side that is, when you look at the sequence numbers, is part of the old conversation. So you get a new SYN, and then you get the, what is it, ACT unseen segment, that is an ACK for the old connection. So in the order of packets, you think you got a new connection, but there's something old still coming in, and then you need to program it in a way or analyze it in a way that you can assign the next packet that is coming to the old one, not the new one. And that took quite like, I don't know, half a day to get this one right. Yeah, that is an extra level of stress that you don't need, but if you're writing an expert system, that's what happens to you. You get packets that you don't expect, and then you need to find a way to assign them again. Because if this happens and you're adding packets to an existing connection, suddenly you'll find out, oh no, I need to create a new one. And then you create a new one and work on the new one, but then an old packet comes in and you need to go back to the previous one. So that is a little stressful sometimes. So let's see what my analyzer says. We run it again. That should be number 4. Number 4. Oh yeah, that was a funny one, I think. There was so many problems in there. So the server doesn't have a window scale option. There's a 0 window on the server. There is a port reuse confusion. That was the symptom that I created for this kind of messing up the stuff there. Reset after teardown. That is because the first was shut down with FINAC, and then the mayhem happened, and then the reset came in, so it's a reset after teardown. I've seen more than one TTL for the server. That is sometimes a reason for concern, because that means that paths of the packets are different sometimes, or somebody may be even creating packets and man in the middling you, if that's a word. And then there is the, hey, I got it, 0 window on SYN-ACK. Yeah, that is like low-hanging fruit, doing that kind of thing. That symptom is low-hanging fruit, but you will never find this if you're scrolling through a trace file, because you don't see it. But the analyzer can see it. Yeah, so that is the stuff that I try to do for you, like giving you all the symptoms, and then you can analyze the conversation where you think, hey, this is not looking so great. And I think the score should be pretty high for this one, probably. Where's my score? Symptom score should be somewhere. The total symptom score, 195. So, this is quite high. I think the highest I had was something like 300 or something. I have a table where the symptoms are weighted. So there's a symptom that is worth 50 points. There's a symptom that's worth 10 points. Like a 0 window on SYN-ACK, I think it's a 10-point symptom. So the scale is no end. It starts at 0 and ends up in craziness. So I don't know. I'm adding PCAP files every once in a while, and I look what the scores are. So far, I think the highest one was 320. It's just adding up symptoms. So the worst case that you could have is adding all the symptoms, so that would be the scale right now. But since I'm adding more symptoms every once in a while, it keeps growing. And I think right now it's about 50 symptoms I have, or more, I don't know. The maximum symptoms that I can have then are 256, because that is a programming language restriction of having enumerated types. So I can diagnose up to 255 symptoms in the end. Okay, so that one was good.
What's the usual cost for the 0 window?
What is the usual cost? Cost for a 0 window on a SYN-ACK. That is actually a good question. Why would a system set the window to 0 on a SYN-ACK? Printers. I think Saka has seen my presentation where I showed that, or you have seen it yourself. I had a trace file, I think 2 years back, where exactly this thing happens. The idea here is you are a very old printer, or I'm a very old printer. Let's say I'm a very old printer because I got the gray hair. So you're sending me a SYN saying, dear printer, print something for me. And I'm like, yeah, I'm going to talk to you. I want to print your stuff, but I'm old. So please don't send anything yet. I'm just telling you, I want to talk to you, but don't send anything yet. I need to spin up my mechanical stuff here because I have no memory. Yeah, so I'm sending a 0 window, and you're like, SYN-ACK, and then it's like, okay, 0 window means we got a connection, but I cannot send you any data to print. And then I will send you a window update saying, hey, all my wheels are spinning, come on, give me the data. You get a window update, and then we go. So that would be a reason for why you do this. We have also seen that in a cybersecurity context sometimes where people are opening connections and then using 0 window to starve you. So, hey, we got tons of connections that have the full handshake, but nothing can happen. So, yeah.
I got 2 questions for you.
2? Okay.
Would you consider doing this in Lua so you can use it natively in Wireshark? 2, do you guys use Bro?
So the first question is, would I consider doing this in Lua for Wireshark? And the second is, if I know Bro. I know Bro, yes. I haven't used it much. It's an interesting system. But writing this one was basically because I wanted to do it myself. And Bro probably can do a lot of this already.
There's some overlap?
Yeah, there's some overlap probably. Yeah. And then Lua is the other thing. I haven't considered it yet because, once again, I wanted to do it myself in an environment where I'm familiar with, and I hate learning a new programming language, apparently, because I'm still on Delphi. Maybe I will do that in the future, but right now this is like an experiment for me, so I do it in an environment where I don't have to spend time on learning things to be able to do my experiment. When I know how to do this and I have everything figured out, because this is a system that is going to be so complex that right now I don't know the scope of it yet. If I have it done completely, I will know what I'm doing, or maybe I will have forgotten half of it already. But then I can do it in the right way. So usually you say the first version of a software you write should never see the light of day, right? I mean, most software does see the light of day, but I try not to. This is just a sneak peek. So yeah, in the end, maybe it will be something like C or Go or Rust or I don't know. Not Python, because Python is too slow. It's very cool, but too slow. Because I want this to be fast. This needs to be able to run maybe at line rate even, for whatever link speed we define. I mean, at a gigabit line rate, that would be preferable. 10 gig is maybe too fast, even if, especially if I do multiple passes. So I don't know, but right now I'm doing this to find out what I'm doing. I'm pouring my knowledge into this kind of thing to see how this can be done. Okay, do I have more?
Your work in Lua, especially when you do the three-way pass, because in Wireshark you only have a two-way pass. System. So, and you're collecting stuff that Lua, is done in Wireshark, it should be in the TCP sector. That will be pretty difficult.
Yeah.
Other stuff.
So Sake just says it's going to be complicated to put it in Lua in Wireshark because of the two-pass system. The question that I was expecting is, why aren't you doing this in the TCP code of Wireshark? And my answer would be, have you looked at that code? Because if you don't have, do it, and then lecture me on it, because I know people who are the best programmers I ever have seen. One friend of us, of Landy and me, who left our company a while ago, he does amazing things. He's like the best guy for figuring that stuff. He's like a genius. And he looked at me once and said, well, this TCP code of Wireshark, I wouldn't touch it with a prong or something because it's too complex. And I don't want to touch it because it may break in places where I don't know what's happening. It's a complex beast, and I'm not touching it either. So I'm building my own system because then I can build it from scratch and I know where I am. And maybe you've seen it. My code looks like it's with a lot of indents and stuff. It's written in a way that it's easy to understand, so I don't lose myself in I could do the crazy C++ or C stuff where you do everything in one line and nobody knows what it is, but that's not the goal here. The goal is to get a system that works and is identifiable and understandable. Okay, so how much time do we have? 5 minutes, right? Do I have 5 minutes? 2. Okay, yeah, I was late. Okay, you want to see another one? Who wants to see another one? Okay, good. Let's see, what do we have here? Server socket clause. Oh, that is a fun one too. I only brought fun ones. Okay, what is this one? That was not good. Make it bigger, rearrange. Okay, you can already analyze it while I'm rearranging columns. What is happening? How useful is this conversation? How much data is exchanged? 0. Why? Because the connection is started, nothing happens, and then it ends. Yeah, one of the dead giveaways for that kind of thing is if you look at the time, 60 seconds is never a coincidence, never. That is something where somebody said, hey, my timeout is 60. Or as I would have done it, 60,000 if I'm doing milliseconds or something. So anyway, this is a connection that I sometimes see. It is something where nothing happens. So let's see what my expert system has to say about this one. Because it looks quite okay. There's nothing broken really, but it's not the useful conversation. So let's check the symptoms that it will tell us. And that would be number 5. And there it is. So the symptoms is only one symptom saying closed inactive. So that is a symptom that I use that when somebody creates a connection. So if you're a client and you're talking to a server, it's like, I want something from you. And then when the server says, okay, I'm ready for you, and then you're like, waiting for 60 seconds, saying nothing, it's like, that is completely useless. So this is a connection that is torn down because of inactivity. And that may be helpful in a way that you say, this is unnecessary communication on my network. Sometimes people tell me, yeah, this is what happens if you have like a monitoring system that checks if your system is still up. But then I'm asking you, why is it keeping it open for 60 seconds? You see it a lot happening since like Finec, like real fast. Like a system checking, is the system still providing that port, is the service still running and stuff. That is fine, but this is not fine. So the symptom, if we would look at the code, will for sure have something like, this needs to be at least this long for the symptom to show up, because otherwise, if it's not that long, it will just tell you this is like a system check or something. There will be a symptom for that, I'm pretty sure. So I think my 2 minutes are up, right? So thank you. I think we did the Q&A already during the talk. This is the way I like it. I hope you stayed awake for some of it. And yeah, see you next time. Thank you.